Yeah, yes, sir.
Yes,
Yes,
sir.
sir. Now,
Yes, sir.
Yes, okay. So can you tell me here there is a speedometer and odometer, like you can see it in every vehicle, right? Can you relate this to differentiation and integration, and tell me which is doing what operation? Yes,
Odometer is doing integration, sir.
odometer is doing
Because
integration. Yeah,
yeah, sir, because it adding some of the future kilometers to next time, sir. But
very
the
good.
speedometer differentiation it reduced to the certain point, sir.
Correct, correct.
It
Good.
comes to zero.
Yes, yes. So yeah. So any other answers? Is there any contradiction answer? Or all of you agree with this? Yes or no? Give me thumbs up if you're agree with this answer. So probably in this class you have to use this thumbs up button. Okay? Yeah, good. Okay. So others are not responding means what? You're not agree with this answer. Okay. Okay. So yeah. So basically, like as I said, like integration is nothing but a kind of addition of insulin, correct? So when you are traveling, when you are driving, so what you are doing, you are means the work done is nothing but the traveling from one point to other point, correct? So uh, yeah, so it's like what the odometer will do, like it will keep on add whatever the work you have done, which means whatever the car it um, travel the distance, right? It's keep on adding. Okay, so it's adding is nothing but integration, correct? So speedometer, what it is doing? So it is helping to analyze at what speed you are going, means at what rate of change your car is with respect to time. Okay, so என்ன ஸ்பீட்ல வந்துட்டு உங்களோட கார் வந்து போயிட்டு இருக்கு, which means வந்து at every second it will give you the status of your function or your உங்களோட காரோட function வந்து கொடுக்கும். So what it is doing, it is going in depth and it is analyzing and it is finding the rate of change, which means it is finding the changes. ஸோ உங்களோட கார் வந்து என்ன ரேட்ல வந்து சேஞ்ச் ஆயிட்டு இருக்கு அப்படிங்கிற ஒரு டீடைல் வந்து கொடுக்கும். ஸோ இட் இஸ் கிவிங் ஃபார் ஈச் அண்ட் எவ்ரி செகண்ட். ஓகே, ஸோ இட் இஸ் கிவிங் தட் ஸோ இட் இஸ் கோயிங் இன் டெப்த் அண்ட் இட் இஸ் கிவிங் த value. So basically that is a operation of a differentiation, and the odometer is a example for integration. Okay, so with this you can understand, right? Okay, now we'll move on to the next one. Yeah. So I would like to give this question. So velocity of a car is given as 50 km per hour. After 4 hours of travel, find the distance traveled by the car. So can you give the answer for this? So car is going with the velocity of 50 km per hour. After 4 hours of travel or journey, like what is the distance traveled by the car?
200, sir.
200. Okay. So how did you find it? Find this?
Speed is equal to distance by time.
Yeah. So speed is equal to distance by time. So we are interested in the distance. So distance is nothing but speed into time. So your speed is 50 km per hour and time is 4 hours. Okay. So you are saying 200 km per hour. Fine. So but in a practical, is it possible to maintain your speed at 50 km per hour for 4 hours? Is it possible?
it's not
It's not
possible.
possible, sir.
It's
Not
not
possible,
possible.
right? Okay. So in that case, like our car will not go the speed. It's not possible to maintain 50 km per hour. So to make it somewhat realistic, so I am going to change that velocity of the car. Okay. So what I will be doing is, see, in practical, car cannot maintain 50 km per hour throughout the journey. So speed of the car will keep on changing let's assume that the velocity of the car is 50 t plus 5, which means what? Your car speed is not going to be constant for 4 hours. Okay, so it is going to keep on changing. So here I am putting in with respect to time. So with respect to time, your speed of the car will change. Okay, so I am asking what is the distance traveled by the car after 4 hours of journey. Okay, so I will just elaborate this one for easy understanding. Let's say at t equal to 0 time. Okay, at t equal to 0 time, the speed of the car is what? It's going to be 50 into 0 plus 5, which is 5 kilometer per hour, right? Right. So at t equal to, for example, 15 minutes. Okay, 15 minutes. So what is your speed of the car? So it is in written in terms of hours. So what you have to take? You have to take 5 into, sorry, 50 into, instead of t, you will be taking 0.25 hours, right? So 15 minutes means 0.25 hours, correct? Plus 5. So what it will come? 50 by 4 plus 5. So 12.5 plus 5, which is equal to 17.5. Yeah. So let's take a t equal to 1 hour. What is your speed of the car? So it is going to be 50 into 1 hour plus 5. So which is equal to 55 kilometer per hour. So this is how your speed of the car will going to change. So now tell me after 4 hours, what is the distance traveled by the car?
205 k.
205 k. Okay. So 205 kilometer. Okay. Right. So any other answers?
Sir, 22, 5, sir, 20.
Sorry. Yes, Ajita. Yeah.
220, sir.
220. Okay.
Kilometer.
220 kilometer. Okay. Any other answer?
But it is also not possible, sir. Due to acceleration, that this is also changed, sir.
Which will change?
Yeah, sir.
Yeah.
There is a deceleration.
Correct. It is not. See, this is also not possible. So that's what I am saying. To make it a little realistic, I am just giving this option. Okay.
Okay, sir.
Okay. But it is somewhat relatable, right?
Yeah, sir.
This is also not real. Okay. Just
Yeah.
for example, I am just taking. Okay. If this is a condition, I am asking what is the distance traveled by the car after 4 hours. Any other answer? We are 20. How many people are here? More than 20 people. I got only 2 response. What about others?
Sir, so now we should integrate the formula with dt.
Okay. What is the answer?
420.
Sorry?
420.
420. Okay. What else? Any other answer? Any different answer you are getting other than these 3? Yes or no? Fine. Okay. So we are getting a 3 response, right? Okay. Let me go with the one by one. So I hope this response, how they are getting is, they are putting t is equal to 4 here, right? So this 205 is coming at t equal to 4. Basically, they are just substituting here. So this is nothing but the equation for the speed, right? So
Yeah.
S is equal to 50 into 4 plus 5, which is equal to 205. Yes, it is 205,
Yes.
but it's not 205 kilometer, it is 205 kilometer per hour. Okay. So
Okay,
the car is going with us at 4th hour. If you are observing at 4th hour means at 4th hour 0 second. If you are observing the car dashboard, so you will be seeing your car will go at a speed of 205 kilometer per hour. Okay.
Okay.
But what we are asking, let's say you are like resetting your odometer at the beginning of the drive. Okay. At the 4th hour, what is the reading of odometer we are asking? Correct? You got it right? Fine.
Yeah, sir.
Good. So how this 220 comes? How this 220 comes? Who gave this answer? So some people what they will do, right? So we know the distance equal to speed into time, correct? So the speed equation is 50t plus 5 into t, correct? So if you do that, what I will get 50t square plus 5t. So now what they will do is they will apply at t equal to, let's say this is d of t, okay? Fine. So they will apply t is equal to 4 here. So you will be getting 16 plus 5 into 4. Anybody got like this?
No, sir.
No, no one got. Is this correct? So here it is going to be 20. 50 into 16, how much? 800. 50, yeah, 800. 800. Is 820 is kilometer? 820 kilometers is correct. How many of are you agreeing? Not agreeing? Come on, give your response. If you are agreeing, give thumbs up. If you are not agreeing, give thumbs down. Okay, good. V is equal to U plus CT. We got two responses. One response is actually this is not a correct answer, because see what you are doing is, see, just take separately. Okay, so this is your speed. Okay, so just forget about this. So let's apply C same. Instead of multiplying and applying, you are just trying to apply 4 here. Okay, so 50 into 4 plus 5. What it will give? It will give 205 km per hour, right? And you are multiplying with the 4, which means what? So basically, what you are doing here is you are thinking that the car is going with the velocity of 205 km per hour for 4 hours. That is what you are doing, and finally you are getting 820 kilometer per hour. Kilometer. Okay. So this is also not correct, right? Because at 4th hour 0 second we are going at a speed of 205 kilometer per hour. But at 15 minutes we are going at a 17.5 kilometer per hour. At 1 hour we are going with a speed of 55 kilometer per hour. But here what we are thinking is for the entire journey we are going. We are thinking that we are going with the speed of 205 kilometer per hour. So this is also wrong, right? Okay. So yeah, I just want to know how this 220 came. So who gave this answer? Can somebody explain? Fine. Okay. So basically you got your, is this?
So when T is equal to 1 is applied, then we get 55 kilometer per hour speed, na sir. Then we are multiplying it by 4, so we get 220 kilometer. That's how we got.
So yeah, is it correct?
No, sir.
Why?
So we have
No,
to
sir.
integrate, sir. Because what they're asking is distance traveled by the car after 4 hours of journey. So it's continuing and it will be stopped at 4th hour. So we have to integrate them, sir.
Why we need to integrate?
Sir, because it is continuing till 4th hour.
So what? See, last case,
We have to integrate them.
started continuing for 4 hours of driving, right? Can you understand my question? Like last case also, the car was driving for from the 0 time to 4 hours, right? There we didn't integrate, but here why we need to integrate?
Because there's change, sir.
Correct. So hope you everyone got right. So why here? See here there is a need for integration. Why means see one more method is there. We can do that. I will tell you. Like one more way. See for this question, I used to get a different like variety of answers. Okay. What people will do, they will think like t equal to 1. The speed of the car is 55 kilometer per hour. Speed of the car is 55 kilometer per hour. So at 2, they will be thinking speed of the car is 105 kilometer per hour, right? 105 kilometer per hour. At t equal to 3, they will be thinking speed is equal to 155, and t equal to 4, the speed is 205 kilometer per hour. So what they will do, they will be like putting 1 here and for first hour 55 kilometers traveled, second hour 105 kilometers travel, for third hour 155 kilometers the car get traveled, and fourth hour it is traveling 205 kilometers. So they will add all this and they will come up with an answer of something like 200, 300, 400, 450, 500, somewhere like 520 also they will come. Again, this is also wrong, right? See, but why I'm saying, because see, we are not maintaining the speed of the car 55 km per hour for 1 hour. Similarly, we are not maintaining 105 km per hour for next 1 hour. So even in the time also, the car speed is keep on changing. So even from first hour to second hour, we will not be going with the speed of 105 km or either 55 km. So it is keep on increasing and it is reaching to 105 km. That is what the statement is saying. So here what's happened? So here we cannot simply just multiply. So this is what we call it as a linear algebra. Okay. So here our speed is constant. So we are directly multiplying it as for the linear algebra. Here what happens at each and every second, the speed is getting changed, right? So it is impossible to see what you can do. You can go with for 1 minute, for second minute what is the car speed, for third minute speed. So with that you can multiply with the minute and you can find. But still here the speed is changing with respect to second, even microsecond, whatever, nanosecond. Okay, so it is changing with respect to time each and every second. So you have to capture all the changes and you have to find the distance traveled by the car for every second, and you have to add up everything. Are you getting my point? How many of you are getting my point? So you have to take care of all the changes. You have to take care of all the and the corresponding the distance traveled by the car for each and every minute, we can say, each and every second, we can say. Are you getting my point? Yes or no? Okay, good. So this is where we need help of integration. So what integration will do? So like we no need to worry about anything. So just by putting an integration, so it will take care of all the changes and it will start accumulating from 0 time to till whatever the time you are giving. So it will keep on adding all those things and it will take care of all the changes and it will give you the integration, right? Okay. So let me give you the what we are going to do. We are just going to do integration and let's see how it is giving out. Okay. So we can define speed. Okay, we can define the speed as a small change in distance divided by small time, right? So which is nothing but instead of speed, yeah, I will take d by dt, which means a small change divided by small time. Okay, fine. So I am interested in distance, so I am putting dd here and s into dt. So I am interested in to remove this different derivative term. So to find the d part, what usually do, we will be doing integration, right? So integration of s into dt. Okay. So what is s here? So our s is nothing but 50t plus 5. So 50t plus 5 to dt 0 to, yeah. So you can put a limit here. So 0 to 4 hours. Okay. So do the what integration, basically what you will do, like 50t means it's going to be 50 t squared by 2 plus 5 of dt means it's nothing but 5t, 0 to 4. Okay. So this is going to be 25 t squared plus 5t 0 to 4, which is equal to 25 16 plus 5 into 4 minus 0. What is the answer? 25 into 16. Yeah, what it's going to be 250.
400 plus 20, 420.
400 plus 20, which is equal to 420. So this answer is the correct one. Okay. So yeah. So you understand, right? Like what integration is doing. So it is taking care of each and every second changes, and it is calculating for each second. It is calculating the distance traveled by the car with the corresponding speed, and it is keep on adding all the value, and it is giving the answer. Okay. It is not doing a simple thing. It is doing some 3 to 4 functions at a time. Okay. So this is where we will be using a like integration, right? So just to give you some idea, I have given this example, right? Okay. So yeah, we will go with the this is fine, right? So hope you understand the power of integration. Anybody has doubt here? Any doubts? Or anybody feeling that not understandable? Can feel free to share. If you're having any doubts, we can clarify it here and we will go to the next one. Okay. No doubts, right? Can we go? Give thumbs up. We can go. Okay, fine. Good. Okay. So yeah. So this is just an some small introduction. Now we will get into that actual syllabus. So as per GATE, so fine. Okay. So if you take the syllabus of GATE, so we'll be seeing calculus as a one division. You can take a vector calculus, and we'll be having a matrix algebra, or you can say it is a linear algebra. And we'll be having a complex algebra. Then we'll be having a differential equation. And also we'll be having a probability. So yeah, so this will cover like most of the domains here. How many of you from electrical? Anybody, any different domains are there apart from electrical, EC, mechanical, civil? Any other domains are there? Mechanical, okay. Any other? So ICT means implementation and control.
Information and communication technology.
Information and communication. So you will be writing which paper? ECE paper, right?
Both computer science and ECE.
Okay. So which one you opted for? Both.
Sir?
Like which one you are going to write? I'm asking. Are you going to write both the papers this year?
For computers, sir.
Computer science. Okay.
Yeah.
So we are having a chemical also. Okay. Fine. Okay. Good. So yeah. So I am just asking is like here and there, like there are small changes will be there, not in terms of the topics, but inside that there will be some extra or maybe a lesser syllabus will be defined for you. So we have to check and then we have to go through. Okay, so we will be having a extra as ICT and chemical. Okay, rest are which we can take it as a computer science and chemical also we are having it. Okay, fine. So yeah, we will be taking. So this is a this is the one we are planning to cover here. Biotechnology. Okay, good. Fine. Anything else? Anybody else? Fine. So yeah. So this is what we are planning to cover here. So we will be covering the calculus, vector, matrix, complex, differential, and probability. Okay. So with this, like you can probably like every year gate will come around. Like I cannot surely say that it will come for 15 marks, but you can expect in the range of 13 to 15 marks. Okay. So definitely it will come in the range of 13 to 15 marks. So if you focus well and if you practice well, so you can easily get 13 to 15 marks. Okay, it's not that difficult. Like it's also like you don't feel that max is just a kind of activity. Okay, so it's not like that. So you have to spend some time to understand mathematics. So once you understand it, like you just treat it like a normal your technical subject because like I want to give this mathematics as a technical subject. Okay, so like you will get some good understanding and once you understand the topics, like you can easily solve the question. So no need to worry about big steps and all. So you have to understand it. Like understanding is very easy in mathematics, and once you understand, you can easily crack any of the questions. Okay, fine. So before we start the actual syllabus in calculus, so let me go with some basics graphs. So it will be useful. Right. So this is nothing but a sine t. So this is your t. So it's basically it will looks like this. So we all know sine t cos t we all know. So at 0 you'll be having a 0. If I take this is a pi by 2, you'll be having a 1 as an answer. Means maximum you'll be getting at pi by 2, and here it's going to be pi. At pi you'll be getting a 0, and 3 pi by 2 you'll be getting -1, and here it's a 2 pi. Okay, so this is how that sine curve will looks like, and yeah, it will go for -5 by 2 here, minus pi, minus 3 pi by 2, and minus 2 pi. Right. So coming to cos, so how it will looks like. So instead of starting like at a 0, it is sine t is having a 0 value, but cos t will be having a 1 at 0. So it will be looking something like this. It will be a shifted version of sine of pi by 2. Right. So it will something it will looks like this. Okay. So here it's going to be 0. At pi by 2 you'll be seeing a 0 value. So at pi you will be seeing -1. Right. So similarly minus pi by 2 0. Right. So this is a cos function. How that e power at will be? So at 0 what you will get? E power at, e power 0 what? What is e power 0? It is going to be 1. Right. Okay. So at e power 0 it is going to be, so this is your t. At e power 0 it's going to be 1. At e power infinity what it will be? What is the value of e power infinity? Sorry? It's going to be, yeah. So exponent, so you'll be hearing rate exponentially increasing. It means what? The increase rate is very high. Correct? Rate of change is very high. That's what exponentially increasing. Which means what? So it is going very exponentially. It is increasing means it is going to the higher rate very fast. That's what exponentially increasing means. So you can relate. Some people used to say because see in the beginning the rate of changing is very small. Means it is it will be changing very slowly. But when it reaches certain point, the growth is very fast. Okay, that's what exponential means. So people will compare this one with the core job and the IT job. Okay, so in IT job you will be seeing some linearly increasing, which means you will be starting at one good salary, and from then our growth will be somewhat linear. Okay, somewhat linear means it will be something like this, straight line. But in a core job, so initially you will end up in a very less pay. Okay, but over the period, once you reach after some time, the rate of your salary increment will be in exponential. Like that at the time, if you compare with let's say both, like you are starting, you and your friend are starting at the same salary. You are in a core domain and your friend is in a like IT sector. Okay, so as I said, like core will take more time to reach here. Okay, maybe your like this, okay? Somewhere like this, right? So let's say when you are reaching some time here, so you will still at this position, but your friend is at this position. Okay, as time passes, so after some particular time, you will be going exponentially. Okay, so your friend is still going in a linear fashion. Okay, that's what the like people used to compare. I'm just giving an idea when teaching. Okay, fine. Okay, so e power 80 means let's consider that a is a positive number, so you will be getting 1 here, and t is equal to infinity, you will be at infinity. Okay, you will be at infinity. Okay, so when t goes to minus infinity, what will happen? What is e power minus infinity? E power minus infinity, it's going to be 0, right? So it is something like this. Okay, so here it's going to be 1. Okay, so same thing, e power minus 80, here a is again a positive number, means how this is going to look like. If you are applying t is equal to infinity, because of minus presence here, so it is going to be e power minus infinity, so that is will give a 0 value, right? So it will go in a like reverse way. Okay, so here it's going to be 1, and here it's going to be infinity, right? Now what is u of t? Anybody here? What is u of t? Just give me a minute. Yeah. What is anybody from electrical background? U of t. What is u of t? No one knows what is u of t. Yeah, come on. U of t particular. Yeah. No signals.
U of t is 1.
U of t is 1. Okay. Okay. Is it 1 means is this going to be u of t? No, right? So u of t is nothing but u of t is equal to 1 when t is greater than 0. Okay, when t is less than 0, it is less than or equal to 0, it's going to be 0. Okay, so basically like it should be like less than 0, it's going to be 0, greater than 0, it is going to be 1. Okay, so this is what called u of t. Basically we call it as a step function. So you remember, right? Step function, right? So what is the signum of t then? So signum of t is nothing but u of t minus u of minus t. Okay, which means that t equal to 1, t greater than 0, it is going to be plus 1. T less than 0, it is going to be minus 1. Okay, so yeah, so this is going to be, this is how the signum of t will look like. So if you do like u of t is this is the function u of t. And minus u of t is what? Minus u of t means, so just a minus of what? Minus of this value, and you are doing a this is scope. I'm just giving here. See, what is this u of t minus u of minus t means? So u of minus t is nothing but it will look something like this. So if plus 1 is like this means minus 1 is going to be something like this, right? Now u of my sorry. So let me write it here. So u of t will look something like this. Okay. U of minus u of t, how it will look like if this is the one. So minus u of t will be looking something like this. Right? Next one. So minus u of minus t, which means, so minus t means what you have to do, you have to take a mirror image of this. Okay, with respect to this, with respect to y axis, you have to take a mirror image of this, which is nothing but this one. So if you take a mirror means, so see, so with respect to y axis, you have to take a mirror means how it will looks like. So it will be looking something like this, right? Right? And you have to add u of t and minus u of minus t. If you add, you will be getting this kind of one. This is nothing but signum of t. Okay, fine. So what is the sinc of t? Anybody here? How this graph will looks like? Sinc. Yes, please. How it looks like sinc of t? Yeah, come on. So basically, sinc of t will look something like this. So at 0, you will be seeing a maximum. As time goes on, that signal amplitude will keep on reduce and it will reach to 0. Okay. So this is what sinc of t, which is nothing but sin t by t. Okay. So this is an expansion of sinc of t. Okay. So at 0, you will be seeing a maximum. Here it's going to be 1. As time increases, the amplitude keep on damping down and it will reach to 0. Okay. T equal to 0, t equal to infinity, you will be seeing 0 as an answer. Okay. Right. So how tan t looks like? So let's say this is 0, this is pi by 2, yeah, minus pi by 2. So tan t will look something like this. Right? So this is going to be pi by 2 means this is pi. This is 3 pi by 2 let's take. So yeah, so it will be something like this. Okay. So this is how tan t will looks like at t equal to pi by 2. So it is this curve is saying a plus infinity, this curve is saying minus infinity. So basically what we will say at t equal to pi by 2, it is not defined, we will simply say. Okay. So at t equal to 0, it is going to be 0. Okay. Yeah, t equal to minus pi by 2, it is going to be like this. T equal to pi, it is going to be 0. So whenever there is a pi by 2 or 3 pi by 2, you can say it's undefined. Okay. Yeah. So coming to here, yeah. Can anybody tell how this log Vp will looks like? Quickly. Do you feel it's a basic thing or it's need to be learned? Why there is a silent? How this log curve? Okay. Yeah. I can tell how this log curve looks like. This is a homework. So we have drawn this much of curve, right? sin k 480 sin t cos t we have drawn, right? So can you draw the curve for like log bt? So I have given 2 log bt, right? So do you think any yeah, why I have given 2 log bt?
Base 10, base E.
Base 10, base E, okay. So B is basically base 10 and base E, okay. So basically, so this 2 log B is for like don't look on to any like don't Google it. Just think and okay, you can take whatever. Okay, so whatever you want to take, you can take either P as like 0, E and 10, or you can take a positive, negative number, whatever. Okay, but don't look on to the any of the graph, any of the Google graph. Just try it by yourself and come up with the solution. Okay, can you do it tomorrow? Maybe tomorrow, day after tomorrow's class. Yes or no?
Okay, sir.
Sir.
Okay, sir.
Okay, try to solve.
So yeah, with this we'll stop here. The next class will be continuing with the limits and the further topics. Okay. So today we have just seen that very basic thing. I hope this will give some good foundation to just to have you'll be having some idea about mathematics, and from next class onwards we will be focusing on the actual syllabus, and still there also we'll be seeing the each and like whatever the topics we are seeing, we'll be discussing the application and where it like some physical interpretation will be seeing. Okay, so if you are more curious, you can just you can just go through the limits, what is limits, and where it is useful and all. So we'll be continuing with the next class. Right? Okay. So yeah, so yeah, we can wind up the class for today. We'll meet in the next class. Thank you.
Thank you, sir.